Okay, today I'd like to show a project that I've been working on for some time. It's a render library that's supposed to make rendering a lot easier than it is today. It uses OpenGL in the background, and it's inspired by Raylib, but it's meant to do a lot of the stuff that Raylib doesn't do. It's written in Odin, and it's specifically meant to be used in Odin. It allows you to specify whatever vertex attributes you want, and makes it easy to upload them to the shaders. Um, and so let's have a look at how one would set up this project and how easy it is to use. So let me start by making a main, uh, and then I'll start by also importing the actual library. Okay. Um, so let's make a window by calling render.init. Now you can have multiple windows. If you make a window if you pass a nil here, it means that you don't create a window when you start the application, and then you're able to make how many ever windows you want with window.make window. And yeah, there's also with descriptor. Those are the same functions. It just takes a struct instead of parameters. Um, so um, I don't want to have more than one window, so I'm just gonna pass a window descriptor here. These are empty right now because the library isn't finished. So window and render the hot window descriptor. So let's fill out this struct. So this will describe how our window will be created, and let's make it 512 by 512. Let's call the title something like Hello World. Let's make the resize behavior to don't allow. You can also, if you wanted to be able to resize, it's called resize back buffer. Um, and the anti-aliasing is going to be MMSA4. Okay. Then we'll pass this Windows descriptor to the library. And let's do render.destroy. And what this should do is just open a window and then close the window. So let's see if that happens. It does. Okay, so let us um, let us keep the window alive. So as long as the window should not close. Of course I need to get the window here. Um, and then we want to do render.begin frame and render.end frame. Right? And then we need to destroy it at the end. Okay. So now we have a black window that's open until we click close. That's great. Um, so if you want to be able to render something to this, we'll do render begin target. And you can pass in target, you can pass either an FBO or a window. And if you pass an FBO, you'll be able to draw to a texture, right? So it's the same for both, which is nice. And you can optionally clear the window. If you pass nil, it won't clear. But if you pass a 4F32, you'll be able to, you know, pass whatever RGB values you want. Let's make a red window, something like this. All right, let's run this. And it's a red. Oh, it was a red window, but we got an error here. And what it's saying is that we forgot to call render.end target. So let's do that. Okay. And now you can see it's alive and well. Okay. Let us now draw. Should we draw some text? Let's draw some text. So to draw text, you do render.draw text symbol, and I don't know, maybe I'll rename this to just draw text, but right now it's simple. Let's draw hello world. And the position is in pixel space. So let's draw it in the left corner, and let's draw it with the size of 10 pixels. Oops, 10 pixels. Okay. Um, okay, 10 pixels is not a lot. Let's do 20. Okay, let's actually just go all the way up to 50 and see what happens here. Yeah, you can see there's a hello world here now. Cool. So that's how you draw text. So just to restate what has been stated, you begin the target past the window, which means that now everything between begin target and end target will render, everything you render in between those two will be rendered to the window. And then we draw some text, and that text ends up on the window. That's kind of beautiful, right? Okay, let's say we want to draw something a little more fun, like a cube or a quad. Okay, I'm gonna get an error, but I think this is nice to show you just how the library treats you. Right? It likes to give you nice errors about what you did wrong. So it says here that you must first begin the pipeline with begin pipeline. Now, so what the fuck is a pipeline? A pipeline is a uh, collection of OpenGL states and a shader. So to begin a pipeline, we say, or to make a pipeline, we say make pipeline. And what it needs is a shader, and then it has a lot of options you can change if you want. But those all have default values, so let's just stick with passing a shader. Now, we can get the default shader by saying render.getDefaultShader. And now we can say render.begin pipeline. Right. And the pipeline also needs a camera. So let's us also make a camera. Now you can make both a 2D and a 3D camera. So let's make a 2D camera for the sake of simplicity here. And a 2D camera has these variables that you need to fill out. And let's just set the position to 0, 0, the target to 0, 0, the rotation to 0, and the zoom to 1. And the near we'll do -1, and the far we'll do 1. So this will be the same as in OpenGL. And this is a left-handed coordinate system, just like OpenGL. And if people say it's a right-handed, they are not referring to the actual OpenGL, they're referring to how we usually make our matrix when we render with the OpenGL. Alright, so we also need to end the pipeline, and we do that like this. Now, we would expect this quad to be white because the color that we are passing here will be white. But because there's no texture bound, it will be black. So let's just show that. And let's make a little bit of space here so it's easier to read. Yeah. Okay. So what's happening here is the draw text is setting a texture and then the render quad in the next frame is reading from the texture that was set. So if we want to be able to actually set the texture nicely, you would actually need to set yeah, you would need to set the texture is what I'm trying to say. So we have a built-in function called get white texture, and it will return a white texture that is 1 by 1 pixel. And now you can see it's white. And if we want to make it pink, you can make it pink. Cool. Okay. Um, so the way that this draw quad works is that the render library has its own mesh of how a quad looks, and then whenever you draw with draw quad, it uses that mesh. But what if we wanted to use our own mesh? Well, then we would have to make a mesh. And to make a mesh, we do render.make. And there's a bunch of different meshes you can make. Arrow, buffered, circle, cone, cube, cylinder, quad, single element, and sphere. All these shapes are just they're pre-filled with data, right? So they're pre-filled with like a circle or cone or whatever. But what we are more interested in probably is something like the make mesh single or make mesh single empty, and the different is the empty one will not have any data and the single one will have data. There's also the buffered. The buffered is if you want to upload often, like every frame, you could have multiple meshes and then swap between them. So you would upload to one and render with the other, and then you would swap the two meshes, and that can sometimes increase performance, and also sometimes it can lower performance. So don't only use it if you actually need it. I'll be using a mesh single here, and now it's beginning to be a little bit interesting. To begin with, let's do something like my data. And let's do something like this. And what do I mean by this? I mean that this data is of type default vertex. It's a slice or array of default vertices. And this is how it helps you get data to your shader, because this default vertex, all it is just a struct, the position, texture coordinate, and a normal. And all that has to happen is that these names has to match the names in the shader. So if we go to the default shader here, it has to match these names, and it has to be defined in this file, which the user defines. And all you need to do is just pass this data here, and that's it. When you do this, all the data will correctly be uploaded to the right place. Um, there are some stuff you can do, and I will document this better. But um, if you want this to be ignored, you can do something like uh, ignore equals true, and then it will be left out of being uploaded. Um, I'll document it a little bit better. It's not done, so yeah. Okay, so let's try and make a triangle. And well, what is a default vertex? Let's yeah, a position. So the position, the texture coordinate, and the normal. So let's make one in the lower left corner. Let's make a vertex in the right corner of the screen. And let's make one in the top center. Um, I think this should be a triangle. Let's see. Um, so to draw this, we'll do. Eh, okay, let's remove the quad and see. Draw mesh, and there's draw mesh single or draw mesh. Draw mesh will just look at whatever type you pass. In this case, it is a single mesh, so it'll draw it like that. And the next thing here is the model matrix, and we just keep it at 1. Of course, we need to write render here. I mean, it is a triangle. It's not the triangle I wanted. Um, because actually the triangle I wanted would look something like this. Yeah, like that, right? Okay, cool. Uh, but let's say we wanted to have some colors on these triangles. Well, if we wanted to do that, okay, you can see I've already defined this here, but yeah. So let's do a new vertex. So let's define a vertex struct, and this one will have position. Um, let's actually just do position and color. So the color is going to be a 4F32, and the position is going to be a 3F32. Right. And then let's replace this here with this one. And let's define a color instead. So RGB. Uh, okay. Let me show you what happens if I do this. It of course, uh, doesn't work because our shader does not support colors. The default shaders does not support color. So let's do a new shader. You can see I've already made a shader, and I'd like to introduce you to how this shader works because it's a little different than just normal OpenGL. I do have a preprocessor that helps you a little bit. Um, to begin the vertex shader, you write add vertex, and then you write the vertex shader code. And to begin the fragment shader, you write add fragment and begin the fragment shader code. You can do include, and then you can include files here. You can do like defines. So I don't know. You can say the component, and then uh, you can pass your shader defines here in the init, and then those defines will be placed in the shader before they're compiled. So it helps you a little bit in the ways that I would like my shaders to be loaded and function. This is how I made it, so hopefully it helps and is not too annoying. Because of course it does impose some more rules on you about you needing to have both your vertex and fragment shader in the same file. Okay, but this pipeline, we would like to load our own shader now. So let's do my shader, and we'll do render.load shader from path, and we'll do the path as just my shader dot glsl, and I can then pass this shader here. All right, uh, let's see what happens. Yeah, of course, when you load a shader, it can fail. So let's assert that it is okay. Oh, sorry, it's passed like this. Is equal to. God damn it. All right, so the shader fails to compile, but I don't know why. This is a good point to show. Like previously, we haven't actually have anything printed when we run this, right? And that's because the library uses a logger. So to be able to view what the library is saying to you, you have to create a logger around the context. And I have a logger that I like, and it is included in the utils uh, part of the library. So let me just include that and do utils.create console logger. And we'll just view only info, or maybe just warnings. Let's do info. Okay, so when I set this, I'll now be able to see the library talking to me, and it'll GLSL. All right. Okay, so you can see it told me that the path was invalid, and it was. I forgot an L. Okay. Um, Now it's complaining about some other stuff. Not all shaders have been unloaded, and that's because before we close the program, we have to stop. Um, we have to destroy its shader. So let's do defer render.destroy shader shader. Sorry, it's called unload shader. I might rename this actually. It's a bad name. Um, so let's do that, and we'll run into an error now. But I want to show you this because I think it's a common place of error. And that is we have called defer here, but still because this destroys here, you know, and the defer will unload the shader when we go out of scope. It's down here. So actually, we won't unload the shader before we call destroy. To fix this, we can enclose this entire thing in a scope. And now we should see that everything stuff unloads destroy here, right? So now you can see when this is closed that we don't get a panic anymore, but we do get error, we do get some errors here, which are saying that we forgot to delete something. And what we forgot to delete is this mesh. So let's also delete this mesh. So this is kind of cool, right? The library keeps track of all the OpenGL applications you do in debug mode. And then if you've got to delete something, it'll tell you that you forgot to delete something. Um, destroy mesh. My mesh. Okay. Let me also just comment on this warning here. This is actually from the driver, and it's just saying that it moves a buffer to another location from video to host memory. Yeah, the driver just does this sometimes, and these are enabled by default, and you can disable them if you want. But yeah. All right. Okay, and now when we close, we should no longer see any errors, and we don't, right? Because we remembered to delete our mesh. Cool. Back to the stuff that I actually wanted to do. I wanted to have colors in here, so let's do color, right? That's what I called it. Color, yes. Uh, and okay, so okay, let's just do this, and it'll tell you what you did wrong, right? So we won't need we'll need the MVP, but we actually don't need anything else. So let's just remove all this. Uh, and out we actually just need a color, and it's gonna be a 4, like that. You can see it's not totally done, right? I'm still working on some of the stuff. Um, so let's call this colors with an S when we go to the input here. Color diffuse. Sure. Uh, let's not do a texture at all. And let's just do color. Okay. So colors is just equal to color. And this is going to be a rec 4. Right. Okay. We're still going to get an error. And it's because this location here should match the location in here. So because this is number 8, it must be that the layout here is 8. Yeah, that that's made for a specific reason. But yeah, now you can see that, hey, we actually have the colors that we placed in our vertex shader, and they get to, or we have the colors that we placed in our program here, and their colors are getting to the vertex shader. And it's quite easy, right? Like, all we had to do was make this name here match this name here. And then it tells you pretty much everything you can do wrong. It tells you that you did wrong, or at least all the common things I've seen. That's nice, right? Okay. Um, I think this is all I wanted to show for today. Um, as you can see, it's. Let me just comment on a few things here. It's not that many lines of code to get pretty arbitrary meshes and colors and such up on the screen. It's very flexible, right? Um, you have access to create your own cameras. Like, I don't believe you have that in Rayleigh, but I think they might have done something in the new version. But in Rayleigh, you definitely don't have the ability to just create new attributes and upload them to the shader like this. Um, and I think that's kind of important. I've made this library with the intent of being used to actually ship games, not just make small, fun toy projects. Um, so there's quite a lot of stuff around that's also there for performance reasons, and some of that, of course, makes the library seem a little bit bloated sometimes. Um, but I do think it is important that you're able to get the performance when you actually need the performance. And so that's why it's there. Yeah. As and it's pretty far, I think. Like you can draw, you can draw instanced. Yeah. Oh, let me just show you something cool actually. So because you know Raylib does this, and I was inspired to do some of the same stuff. You can draw the FPS in the corner if you want. Uh, window. So if I do this, you'll be able to see how many FPS we are running up in the left window. That's a lot of FPSs. Actually, let me also just enable VSync. So render dot wait dot enable VSync. Okay, let me also show full screen actually now that we are doing all this. Hello? Yeah, okay, my headset of course just went out. But as you can see, we are drawing at 120 FPS because now VSync is enabled. And I want to also do full screen. So enable full screen. And yeah, you choose which window, of course, because you can have multiple windows. So we are setting the main window in full screen mode, and there you go. So yeah, uh, I think it's pretty easy to work in. It's quite flexible and it's quite fast. Um, some things are not done, and some things might seem complicated depending on who you are. Like if you're coming from Raylib and expect it to be as easy, you might hit some things where like, why is it like this? But then the reason is, oh, that's because, then you get 10 times the performance or something. So I think it hits a nice balance between performance, ease of use, complexity, and yeah. That was all for today. I hope you got something from this video, even though it's not done yet. I hope you can see where I'd like to go with this project. Alright, thank you for watching.